Now, question 6, we're given two small identical spheres, A and B. Now, they are suspended on a long string as shown in the diagram. Now, the spheres carry a charge of, so this one, it will be plus 5 times 10 to the power negative 9 coulombs. And this one, it's negative 2 times 10 to the power negative 9 coulombs. Now, remember, if these were 2 nanocoulombs or 3 nanocoulombs, what you would have done is that you would have taken this 7 and you would have multiplied it by 10 to the power negative 9 to find your coulombs. Same applies with this. You'd have taken this 3 and multiplied by 10 to the power negative 9 to find your coulombs. Now, if you were given a microcoulomb, which looks something like this, to find your coulombs, you'd have said 7 multiplied by 10 to the power negative 6. Same applies if you're given 8 microcoulombs. You'd have said 8 multiplied by 10 to the power negative 6. And these would be equivalent to your coulombs. All right. Now, remember these units where every time whenever you are given these. Now, the first question, they want us to state the principle of conservation of charge. Now, conservation of charge simply states that basically the net charge of an isolated system remains constant during any physical process, right? So net charge, so the net charge, which is your Q net, right, of an isolated system. Now, what is an isolated system? This is a system whereby you don't have any external forces which are disturbing. For example, there is no air friction, right? It's an isolated system. There isn't any disturbance. So the net charge of an isolated system remains constant during any physical process. All right. Now, moving on to the preceding questions that we given. So now we are told that, all right, the two spheres are brought into contact and then separated again. Now, which sphere, A or B, would gain electrons? Now, let me explain what would happen. Now, when these two spheres come into contact, what would happen is that there would be transferring of electrons, right? So there would be transferring of electrons. Now, your electrons, there are two scenarios. So normally, your electrons, they move from a negative terminal, right? So normally electrons move from negative to positive, right? Move from the negative sphere to the positive sphere. This is the first scenario. The second scenario, now, if we were to answer this question using the scenario or using this reason, we would have said, okay, the electrons or the sphere that would gain electrons would be A. Now, our reason, we would say electrons move from your negative sphere, which is B, to the positive sphere, which is A in this case. Now, for the second reason that you may give, you could say, or rather, let me start by writing down the other reasons. So your electrons move from the sphere, right, with the highest charge to the sphere with the lowest charge. Now, when you're determining the size of your charge, you do not take into consideration the signs which are here. So these signs, they are there to determine your direction, basically to determine whether your two spheres, would they attract or would they repel, right? So for let's say we had something like -7 coulombs and +2 coulombs. Now between these two, or these two charges, which one would be bigger than the other? So this one with the 7, it will be bigger than this one because this has more negative electrons than this one with positive electrons, right? So because this one, it has a greater charge, which is 7, and this one has a lower charge compared to that, which is 2. Electrons in this case, they would move from this sphere to this sphere, which has 2. Right. So it's important for you to know that when you're determining the size of your electrons, you do not take into consideration your signs. Right? These signs are there to basically determine direction, whether your two spheres, would they attract or would they repel. So now, to answer this question using the second principle, when we're comparing the two, clearly you could see that 5 is greater than the 2. So you would say B is going to be the one receiving, right? So they would move from A to B. And your reason would be electrons move from the sphere with the highest charge to the sphere with the lowest charge, right? Or you could make it in terms of electrons. Remember, your charges are directly proportional to your electrons, meaning that the higher the charge, the higher the electrons. The lower the charge, the lower the electrons. So here, instead of you using a charge, you could also use electrons. You would say they would move from the sphere with the highest electrons to the sphere with the lowest electrons. In fact, yeah, just use your electrons. Do not use your charge. Just use this electrons. So there are two answers. The first answer, it could be, it was our A, and our reason is that they would move from negative to positive. Now the second answer, we said it's B, and we said the reason being is that electrons move from the sphere with the highest electrons, right, to the sphere with the lowest electrons. Now, 6.3.1, calculate the net charge of the two spheres during contact. Now, how do you go about calculating your net charge? So basically, when you're calculating your net charge, the formula for your net charge, it will be equals to the addition of your two charges, right? Q1 plus Q2. Now, it's important for you to note that when you're calculating your net charge, you would include your signs. So for this, Q1, let's say this is A, and Q2 it's B. So our Q1 is 5 times 10 to the power negative 9, plus our Q2, which is negative 2. So this would be minus 2 times 10 to the power negative 9. Now adding these two, this would be the same as 3 times 10 to the power negative 9 coulombs. 6.3.2, they want us to calculate the charge on each sphere after they separated. Now remember, to calculate the charge on each sphere after the separation, you use this formula. Your Qu, it'll be your Q1 plus your Q2 all divided by 2. The same applies here. When you substitute your Q1 and your Q2, you would include your signs. So you would include your signs. So our Q1 is 5 times 10 to the power minus 9 plus our Q2, which is negative 2 times 10 to the power minus 9. Now all this divided by 2. Now punching this into your calculator, your Q new should be equals to positive 1,5 multiplied by 10 to the power minus 9 coulombs. Now for the last question, 6.3.3, which is calculating the number of electrons transferred during contact. Now to calculate the number of electrons transferred during the contact, so you could use the formula of Q is equals to N multiplied by QE, which is a constant. Now remember that your QE, you should substitute it as a positive value. This constant is given as negative 1,6 times 10 to the power minus 19, right, in some formula sheets. So make sure that you substitute it as a positive value, so you would exclude this negative, right? Now, we know that Q is a constant. What about N? N is what we are looking for. This is the number of moles, or rather, the number of electrons transferred. Now, with regards to your Q, you can use whatever sphere. So I'm going to use sphere B, right? And my Q, it basically is my change in charge. My charge after, or B, if you're using B, minus your charge initially. So always your Q, it's your change in Q for either A or B. So you will choose which one you want to use. I'm going to do both, but I'm going to start with B. So remember, writing that formula here, multiplied by QE. As at Q, it's going to be the I charge, right? QB, the charge of B after minus the charge of B initially or before. This would be equals to N multiplied by QE, which is a constant. So it's 1,6 multiplied by 10 to the power minus 19. Now, remember here, I've calculated the charge on each sphere after they separated, right? And I said the new charge on each sphere is going to be the 1,5. So the charge of B after it's separated, as well as the charge of A after it's separated, is going to be the 1,5. So my QB after is 1,5 minus, initially, my charge of B is negative 2, right, times 10 to the power negative 9. So also let me put this to be times 10 to the power negative 9. Minus my QB initially, as I said, it was minus 2. So I'm going to put it in brackets, minus 2 times 10 to the power negative 9. And this is equals to N multiplied by 1,6 times 10 to the power negative 19. Now, remember, you're solving for N, and N is multiplied to this bracket. So to get rid of this bracket, you're going to divide both sides by the bracket, 1,6 times 10 to the power negative 19. Also, what you do on the left, you must do on the right. 1,6 times 10 to the power negative 19. So these two would cancel out. Now, punching this into your calculator, your number of electron transfer should be equal to 2,19, rounding off your answer to 2 decimal places, times 10 to the power 10. These are the number of electrons that were transferred. Now, I use B, let me use A. So if I'm going to use A, right, I should also arrive to the same answer. So when I use A, I would say, right, Q is equals to N multiplied by QE. The Q of A after minus the charge of A initially. This is equals to my number of moles multiplied by my QE, which is 1,6 times 10 to the power, let me see here at the top, negative 19. Now, my QA after, remember I said the new charge on each after is going to be 1,5 minus the initial charge, whereby it was 5 times 10 to the power negative 9, so it was positive. This is equals to n multiplied by 1,6 times 10 to the power negative 19. And because I'm looking for n and it's multiplied to this 1,6 times 10 to the power 19, negative 19, I'm going to divide both sides by 1,6 times 10 to the power minus 19, so that these two could cancel out. 19. And your n, this punching it into your calculator, you should get 2,19 negative, by the way. So one must be positive, one must be negative, times 10 to the power 10. Now this is if, right? This is if you use the A, right? So if you use the A, your answer would be a negative. But remember, your number of electrons cannot be negative, right? So your final answer should be in a positive form, 2,19 times 10 to the power 10. So always make sure that your final answer is positive, right? So here, as I've said, it's either you're going to use B or you're going to use your A. Do not do both because you will still get to the same answer. So you just choose one which you would need to use, right? Always remember that this Q here, it is your after minus your initial with regards to your charges. All right, now that'll be all for this question. In the next question, we're going to be continuing with question 7, which is an electricity question. Make sure that you stay true.